third-party OEMs to all the vendors that want to run them. So you can download the documentation for how, for instance, TIBCO Rendezvous actually works. But also, if you could take over the messaging layer in these systems, well, you have all the components talking to each other. You can spoof other client responses, you can inject commands, you can do all sorts of stuff. Plus, the message libraries themselves, the things that implement these message protocols, are libraries linked into the program. So if there's a buffer overflow in, I just got a new message from this name in the protocol, right? And if that name is too long and it triggers a Stack Overflow, that's linked into the library running in the agent or running in the server. So is it possible to break the message-oriented middleware layers in these systems? Absolutely, it is possible. We've done it. We have 3 advisories backlogged on this. None of these are particularly interesting advisories. They're straightforward attacks where if you go and look at these things, if you pull up the protocols in a sniffer or in a proxy and you find strings and you make the strings longer, you add AAA to the end of the string, you're going to find your EIP register at 0x41414141. Right? It's really simple stuff. You just have to know exactly which part of the system to attack. The message-oriented middleware layer, these are protocols that are bound to init or any running on arbitrary ports. If you just know the port to connect to and you send the right message, you've taken over not only that one machine, but the whole messaging layer for the entire. This is one interesting thing to think about, and I already mentioned a little bit already, but again, for some reason, even when people aren't using Corba, they all feel compelled to have some kind of application layer naming, where every agent and every server in the system has a high-level, user-visible name. And these names are registered. For instance, a new agent connects into this whole mesh of agents and servers and all that, and it registers itself, and its name is almost always just the DNS name of that system or whatever the Windows name is for that system. But for some reason, they have to have an application layer naming thing for it as well. And that name is how messages get sent to and from that agent, or to the server, the source for the message and all that. They're just like IRC nicks. It's exactly the same concept. And it's exactly the same attack. If you can cause any of the components in that system to crash, and you connect back to the server, and you register yourself with that person's name, you'll collide. Except that you're going to sit there and hold and park on their name, and then when messages come to that box, you're going to be able to intercept the messages in the middle of the messages and things like that. So any place where people do client-level naming, you have an additional attack where if you can DOS the server, or crash it, or crash the network, you can claim people's names and hijack them.
So, I mean, this one's also pretty straightforward. Actually, I'm going to kind of go off the map a little bit here because, we've been doing so well on time already. But one thing I just wanted to kind of communicate about what it is we're talking about, and then I'll definitely come back to this, is just that, think about the sheer number of protocols we've talked about inside of one of these. Like, Tom, give an example of like what's the most number of protocols you've seen in one given enterprise management application?
BMC Control M has the most number of protocols I've seen in it.
How many is my question?
I'm going to, off the top of my head, say 8 or 9.
That's 8 or 9 proprietary, potentially proprietary protocols. I don't know, I'm not speaking for what's actually in Control M, I'm just saying, 8 or 9 protocols, some of which are proprietary, inside of one of these, and you've got maybe 5 to 10 of them running inside of your organization. That's a lot of proprietary protocols going around. That's a lot of untested code that's going around. And people are going to start looking at it a lot. Like, I really think that, as sure as I am that Corba is the way of the future, I'm sure people are going to be looking at this. The final thing, this is the final one. Right?
This is.
All right. So I hit on this earlier. Inside of internal applications, a lot of times they don't do the same level of segmentation. There aren't internal firewalls protecting things. You can usually communicate directly with the databases that are housing all of the information related with one of these enterprise management applications. They're often unpassworded, or they have a default password, and very few people have any idea that there even is a database password set up on one of these. I'm guessing that most of the administrators you talk to of these applications, 50-50 shot that they even know what the password is, or if there is actually one on the database instance for the application.
Like we've already said, I mean, I can think of at least one instance of an agent-based management system where there's literally multiple message-oriented middleware layers, each of them having all the same attacks as every message-oriented middleware layer. 2 sets of different naming contexts, 2 sets of different binary protocols, all the same stuff. So these systems are ridiculously complicated, and every wrinkle in these systems is an avenue to attack them. And 30 plus advisories say these will actually work if you go look at them, and please race us and get advisories out because it's taking us way too long to get these things disclosed and it's bothering us. So why did we tell you all this, and why did we go through all this? Well, number one is that these systems are a threat. They're sitting there on your network. They're bots that you've already installed, just waiting to be misused by people. And if you run a network, your IT people have installed these things without you even knowing them. If you look at your desktops and you find these random little things listening on ports, they're asset management applications or configuration management applications or making sure your software is kept up to date, that kind of stuff. You have to treat those things as if they're incredibly sensitive, high-risk applications. You have to treat them as if they were the moral equivalent of Windows Remote Desktop. And why bother locking down Windows Remote Desktop and making it hard to get into different machines if you're just going to leave this back door wide open for you? So if you're an operator, if you're a security architecture, you need to be talking to the IT people on your network. You need to be cataloging what agent-based applications you're running, what are the agents running on your servers, how do they communicate, what are the different vectors of attacks there. And then as advisories come out, you're going to be more and more credible telling people, well, look, each one of these protocols is a possible way for somebody to take over 10,000 machines on our network. You have to be locking this stuff down.
I think from a vulnerability researcher perspective, if you're trying to help secure systems, this is an area that desperately needs attention, right? This is something that businesses rely on to operate their IT organization, their IT environments. And it's been just completely overlooked, even worse than the other things that we talked about earlier on in the presentation. When we were talking about printers and things like that. This is a far greater problem, just that the amount of attention it receives is next to nothing.
So where are we on time?
We're time to just, how many people have questions? Can I just get raise a hand? Okay, so we don't have that many questions. We could probably go a little bit longer, but we're in like a 10-minute window.
We should just, so originally, and there was minimal chance that we were going to get through this, even in the original set of slides. But I have these slides, we're going to publish these slides, and we're going to publish tools with them as well. But we wanted to talk about protocol reverse engineering. It's a hobby of ours, taking proprietary protocols and stripping them out and figuring out how they work and all the ridiculous, crazy, stupid things that we find. Base 64 with the characters jumbled, XOR encryption, all this crazy stuff and what we actually do about it. We have a set of really simple tools. We have a binary interactive netcat that lets us send arbitrary hex bytes to a connection, keep the connection open, shovel crap at it. We have a really nice, simple plugboard proxy. All these things are just, they're free. They're linked off of our blog. You can just download them and play with them if you wanted. We want to talk a little bit about that, but there's no way we're going to get through this right now. So we'll post the slides. They'll probably read better than us speaking to them anyways. So that's out there as well.
Yeah, and I'd also say that a lot of this section is also based on some of the posts on our blog. So if you go to our website, you can probably get some of that information directly and not in slide form, but more in a Tom Tacek narrative. And why don't we just jump right into questions, because we're... One
other thing we want to talk about in terms of reverse engineering protocols, tools to reverse engineer protocols. Our partner, Jeremy Rausch, has a talk in a couple of hours. I promise Jeremy Rausch will be better set up for AV, and that we will see this stuff coming. But Jeremy Rausch has a protocol debugger. You can set breakpoints and protocol fields. You can single-step protocols. You can use it to reverse engineer protocols. You can use it to build your own proxies that will exploit vulnerabilities in protocols. We're releasing that today. We're talking to people about it. We have a talk about it. It's coming up next. Those of you who have questions. You're right. We said we haven't tested all those vendors. We want to give. That's a fair point. I think we just wanted to make sure that you're right. I'm sorry.
It's actually not one specific. You're being a little facetious there. So, but I address it.
You're okay with us naming your company? We can't say anything about the security of BigFix, and Ryan's a smart guy, so I have high hopes that they've done a variety of things right. However, we've tested at least one agent-based management system designed for security, ironclad, rock-solid security, completely wide open. So write up a document about the stuff that you guys have tested. It's incredibly valuable to customers. They want to see this stuff. The people that are evaluating these things, figuring out how to deploy them, They want to know what the protocols that are running there. They want to know what kind of traffic is going through them. They want to know what the exposure is. So vendors like you, I agree. You're right. You guys aren't named in this talk as a target of ours. You guys should write out documents to inform your customers about what the protocols are. That would be incredibly helpful. But big fix. Good guys. Question over there. The question was, do we have any expectation of when the advisories will be coming out? Well, we have now our statistics about how long it takes after we publish exploit code to a vendor and traces through assembly code to how long it will take for them to get back to us. Our current estimate about that is infinity. I don't have a good answer. What I'd really love to find out from people is what are some better tactics that we can use to prod vendors along. So we have a variety of ways they can come back on you and say, well, these are internal applications, or it's going to take us 9 release cycles to fix this pre-auth buffer overflow in a public service running on, bound to a network port. We're on a panel tomorrow about vulnerability disclosure. I hope to yell a lot about how hard it is to get things disclosed. It is the #1 problem we have finding new vulnerabilities, is figuring out ways to let customers know about them. We take every avenue that we can possibly get. For instance, sometimes vulnerabilities get fixed and they get put in the bug tracking databases.
I'm gonna cut you off on this question just because the answer is we don't know. They're gonna trickle out over time. We just have a number of other people have questions and I want to make sure we get to them. So this guy next.
If you're a Jericho believer, don't install agent-based management applications. They create a transitive trust situation where every machine is implicitly bound together and shares all the same credentials. It is the polar opposite of hardening every individual endpoint. I'm not a Jericho believer. I think firewalls and perimeter security has been one of the most successful things that we've done in computer security. It's the reason why the New York Times doesn't get defaced every day anymore. However, there's a lot of good thought that goes into the Jericho ideas of hardening machines, making machines survivable, and yeah, the notion of agent-based management applications, it's a good question to pose to a vendor as to how that could possibly be compatible with that goal.
Okay, then you. So.
No.
Absolutely not.
In fact, not only are they not limited to Windows, they're not limited to personal computers, they're not limited to servers. Mainframe runs some of these applications. The part of the value prop of an agent-based management application is it's cross-platform. It allows you to manage all these systems at the same time, and it allows you to take over all these systems at the same time. There are definitely Windows-specific agent management applications, but there are also heavily cross-platform agent management applications.
All right.
That's a good question. The question is, do we have examples of best practices or solutions or parts of solutions where agent-based management vendors have gotten it right? And I'll tell you that our answer to how agent-based management vendors can come close to getting it right has to do with locking down every endpoint in the system with TLS and client certificates. One slide, I just have to get to this slide because it's my favorite slide ever, and you can probably still see it. Vendors should not be allowed to write their own encryption. It's time we all stand up together, let facts be submitted to a candid world, ban vendor-implemented crypto libraries. There's only one answer for securing a connection and any new protocol that gets deployed. It's TLS with client certificates. The picture on the top there, the words top secret, the picture on the bottom is that same block, that same bitmap encrypted with ECB encryption.